I really am of the belief that we are meant to be connected to nature, right? So modernity, with all its incredible facilities,
I
if it
mean,
were
we
not for
evolved from a biological perspective. We have, I mean, our ancestors, and we inherited their genes, co-evolved, you know,
absolutely
and adapted to being in natural environments. Yeah. So,
100%. I mean, and stuff that people took for granted and did just as a matter of course, say tilling the land and sort of getting their hands dirty with earth.
mm,
It turns out, biologically speaking, I mean, it isn't a huge surprise if we think about it. The incredible benefits, mental health benefits, physiological benefits, which is very, very interesting to think about. That somehow, despite all our incredible advances technologically, I mean, if it were not for technology, and this is sort of the paradox that I have to grapple with all the time, like it's as a result of technology that I'm connecting with you right now, and so forth. And so this remarkable, I mean, this is maybe part of the paradox of being human. The sort of the material, the deep materiality of things, and the sort of, to use a type of religious language, the sort of the spirituality almost that's imbued in it, which sort of makes me think a little bit about your work. It's very fascinating, the little that I've had a chance to look at. It's way beyond my comfort zone.
you mean my research or my book? Which one?
Your book. I mean,
Okay.
just exposure to the Google talk you gave and a couple of other online videos I've had the chance to look at briefly. The sort of, for want of a better way of putting it, but for me, I mean, as a musician myself, music is deeply spiritual, and
Oh yeah.
the aesthetic dimension is.
Right. What instrument do you play?
Pardon? I play the guitar. I play the guitar. I have a very sort of interesting, well, maybe. So I'm heavily influenced by a multiplicity of genres, and I find myself more and more, whether consciously or unconsciously, incorporating a lot of Eastern sounds into my musicianship.
Are you familiar with the Indian guitarist? He plays electric guitar, Prasanna.
No.
Ooh,
I need to check.
man,
Yeah.
oh my goodness. Okay,
Yeah.
Prasanna is. Oh man, he's managed to have his electric guitar. He plays. I saw he plays with Vijay Iyer a lot, and my friend Srini Reddy, who's a sitar player.
Yeah.
But Prasanna has managed to tune his guitar electric.
Yeah.
I have like this sitar sound.
Oh, nice.
But it's hip, man. It's like
Yeah.
It's like Vernon Reid on like playing electric guitar sound like sitar.
Oh, beautiful. I love
alternative. He's on that level too, you know.
Sure. No, and I appreciate your recommending that. Given that you're a very serious musician as well, I'm very interested in sort of alternative tunings. I've recently discovered, I'm sure other people have discovered it before me, but I feel like I just discovered a mode of tuning, and it creates a very different sound. So I was hoping you could speak a little bit to, on the one hand, the way physics very often presents itself, or is presented, I mean, doesn't present itself, as this sort of world which is, this is in very layman's terms, of course, coming from me right now, as being fundamentally concerned with the physical world, right? Hence physics itself.
That's right.
And it strikes me that you're bringing this deep spiritual dimension to bear on it, and how, looking back historically, the sort of the specializations in the various sciences that we now recognize today, these are, historically speaking, relatively new. Historically, some of the greats, of course, were multidimensional in their thinking. They were musicians as much as they're metaphysicians and so forth, and physicists in the modern sense. To what extent do you think we require as a species to bring back bring the sort of various disciplines back together again in order to think through some of our seemingly intractable problems today?
Yeah, just that last part of the question, just to make sure that I want to make sure that I really address your question. Just ask that last part again one more time.
So, given some of the seemingly intractable problems that we're facing today as a species, to what extent do you feel, because this is my feeling, maybe I'm imposing this, so forgive me if I am, but I can't help but feel that we need to bring the various disciplines back together again, almost in some very complex conversation and improvisation, even to use that jazz notion.
Yeah. So definitely, like in the exploration in my book, you know, I mean, even the title of the book, right? Jazz Physics, the jazz of physics. The book wasn't the physics of jazz; it was explicitly the jazz of physics.
Yeah, yeah.
So because you have physics, let's say the laws as we know them, and you know, just so that everybody's on the same page, it might be useful to kind of give a executive summary of where we're at.
Please do, please, yes.
No, okay. So what we know is that there are four basic fundamental forces or interactions, some of which we're very familiar with. Electricity and magnetism. We've all played with electricity and magnets as kids, electronic gadgets. Gravity, I mean, what's keeping you glued to your chair right now? What's making the earth go around the sun, the moon go around the earth? The solar system is a stable, you know, body of planets going around the sun. Is all controlled by this force called gravity. Then we have two other forces or interactions that happen at the more subatomic scale. So when we now go into take hydrogen, hydrogen is really just an electron orbiting a nucleus, positively charged, that's a proton. Actually, that proton is, there are atoms of even tinier constituents that make up the proton. These objects are called quarks, okay? And these quarks, you can think of them as also elementary particles that are held together by a very strong interaction. That's actually called a strong interaction. It's a nuclear interaction. And then also active in that nuclear realm is something called the weak interaction. So there are four forces. And we believe, and we understand the nature, meaning what we call the behavior of those forces with incredible precision. You know, we're talking about if nine decimal places of accuracy, right? So so just to give you an example, let's say that I write down a mathematical, so we actually have equations of physics that describe if I do this, this happens, right? For all these forces. And the precision is such that I can write down this equation. It's literally one equation. And it's amazing that this one set of equations, an equation that contains some more equations in them, like has the economy to describe phenomenon all the way from, a billionth of a centimeter all the way up to a galaxy, right? That one set of equations, right? And what's interesting there is that so I'm going to tell you all the good things, all the correct things. Of course, I'm going to tell you the bad news in a second. So the good news is that physicists have employed the strategy of how we discover these laws. It was really nailed by Albert Einstein. Einstein realized that basically there are hidden symmetry principles that these laws seem to, they are constrained by, or that these laws they succumb to. These laws basically obey symmetry patterns, okay? And so that's one of the reasons why we're able to, with using our minds actually, and experiment and observations, figure out what these laws are.
Right.
And an example, just to give you an example of the precision, let's imagine that I have an equation that predicts the distance between San Francisco and New York City. Let's say that. And the equation makes a prediction and says, oh, it's 2,000.1 miles. Well, I'm making that up. And then you go and measure that realistically. And
exactly.
that precision is the thickness of a human hair.
Wow.
So that's how precise these, so that's how well we understand these basic interactions that I just told you about. Really? Now, the problem, and so that's good, but if we had figured those out, if that was the end of the game, then I and my other colleagues around the world at different universities and research institutes, we wouldn't have jobs.
Because that'd be it, right? Yeah.
That's called research, right? And right. So clearly there are problems, and those problems are actually plentiful. So, you probably heard about things like dark matter. There's some invisible form of matter that's causing galaxies to rotate faster than they should be. These things have been observed. We see the evidence of dark matter in how, because matter bends space, as according to Einstein's theory, and then that space will make light warp. So we see this warping effect due to this dark matter. We see dark matter in this imprint in the early universe called the cosmic microwave background radiation. So we have these many different ways of seeing that there's dark matter out there and a lot of it, okay? In fact, most of the matter in our universe, we're the minority. Visible matter, the stuff that you can touch and feel, the atoms and you and me, that's a very small part of the pie, right? Most of the matter over 75% of the matter in the galaxy, for example, is dark. It's invisible, but it has the effect of creating motion, and it's like a poltergeist. You see a chair move, and you can't account for what's making the chair move. So you call this thing a poltergeist. So dark matter is a cosmic poltergeist.
Is it? May I just very quickly ask? So if I remember correctly, again, this is coming from a complete layman, total novice in this area. If I remember correctly, I heard a while ago that dark matter is hypothesized, but that scientists, physicists don't really know much about it. Is that correct?
Right. So
you're going
when I talk about all these physical laws that we understand, dark matter is something we don't understand. Right. We don't know its nature. We don't know what its identity is. We don't know how it even fits in the pattern of the things we do know, even though it gravitates. So we know about its properties, but many of us in the community believe that dark matter actually has hidden properties that have yet to be unveiled. We also, some of us believe, myself included, that if we crack the code of dark matter, it might lead us into a new portal into understanding, like some paradigm shift in physics.
Wow.
And I can speculate on that in a second. We also have this other form of energy called dark energy. And again, it's actually most of the energy in the universe, right? Wow. And so again, we don't know how it fits in the pattern of the rest of the stuff, of the visible energy in the universe, like sunlight, right? Right. So you have those things, but then there are also foundational issues in physics. So for example, though we understand quantum mechanics very well, and we can now hone quantum mechanics for actually our technological devices or quantum devices. Your cell phone is a quantum device. It relies on the laws of quantum mechanics, right? Those semiconductors, you need to solve the equations of quantum mechanics to understand, to actually manipulate your cell phones, right? The engineers are using
so I had and have heard of quantum computers and quantum computing, but we already have this in the form of semiconductors.
Yeah, that's right. They're not exactly quantum computation going on in the cell phone, but the way the electron is behaving, the electron is a quantum particle, and to manipulate the electron at the precision that we need it, and there's certain properties of the electron, actually, we exploit the quantum nature of the electron to do sort of the logic, the devices in your cell phone. So basically, your viewers can look up a device called a MOSFET. Okay,
How do you
MOSFET.
spell that?
I think it's MOSFET. Okay.
Yes.
So I think that it's basically a transistor. And I taught a class on these solid state devices. It stands for the metal oxide semiconductor field effect transistor. That's what it stands for. And it uses the quantum nature of the electron, right? Your computer has these transistors in it. Your electron, your cell phone has it. We're in a quantum era. But check this out. It turns out that even though we can use and exploit quantum mechanics, there are philosophical problems, unresolved problems, ontological problems with quantum mechanics, right? Epistemological issues with the interpretation of quantum mechanics that physicists all disagree on. Some people call some of this thing the measurement problem, or some people call it spooky action at a distance or non-locality. But these are all things that these problems, they kind of strike at the heart of the way we think we perceive this physical world and interact with the physical world. We don't perceive the same way we don't perceive time bending and slowing down for different people, right? But theory of special relativity tells you that that's because we're moving in a world where things are moving very slow, relative to the speed of light, 186,000 miles per second, right? If you're moving at those speed, then you will experience, actually, nature will reveal that part of space and time, that time can slow down relative to other observers, right? Moving slower. Likewise, in quantum mechanics, we don't perceive, if I nudge something here, it has an immediate effect on something else on the moon. That's like a non-local spooky action at distance. We don't perceive that, when I look at an electron, I see one electron being 50 places at the same time. And when I go to look, it just completely collapses into one place, right? So quantum mechanics seems to, you need to invite, if you want to believe all the great stuff it does for you, that's the baby, the bathwater, or all of these weird things that you kind of have to accept about how, about nature, about physical reality, that physical reality doesn't quite seem as physical as we directly experience it, okay? I don't claim to have any more insight into that, because simply speaking, these are unresolved, highly debated questions. But then there's this famous saying, shut up and calculate. Don't worry about those philosophical issues. Just go ahead and, if you calculate, you'll get the right answer, and you can build nice devices, and you can still make way by doing this. However, as we're entering
this saying is amongst physicists and technologists, I imagine.
Yeah, there's a famous saying, shut up and calculate. And I forget who said it. Maybe it was Feynman, maybe it was Wolfgang Pauli, maybe it was somebody else, but basic idea is, maybe it was Paul Dirac. Arguably one of the founders of a field called quantum field theory, or relativistic quantum mechanics, merging relativity with the quantum. So going back, I just had to I felt it was necessary to give that kind of.
No, that's beautiful. Thank you. Yes.
I would say that, in the jazz of physics, one of the things that I felt compelled to do, just as a research physicist and a practicing and sometimes working jazz musician, I played a saxophone. I'm mainly the tenor sax. One of the things that I felt I needed to do was to reconcile those two practices in those two worlds for myself, because I realized that as I matured as a physicist, and as I even started to have my own research group and was responsible for mentoring the next sort of like my graduate students and my postdocs and even my undergraduates, I found that the way that I would naturally engage them in research was of a more improvisational nature, was of a way where it was more informal, where you had to really have very sharp technical chops, no doubt. You really had to know your stuff, know your math and that stuff. But the way we interacted felt like a jazz quartet, right? And meaning that, like, you know, if someone would say something, I would kind of want what they were saying to be speculative and wrong sometimes. I would kind of want that, because for me, I would, if a student would say something, if we're working on some unknown problem, even if that problem was of a technical nature, of a mathematical nature, I would embrace and really encourage them to actually to step outside and play that wrong note. So, you know, so that I can take that, manipulate it into something interesting and throw it back at them. And it'd be like this boomerang effect where we would be, you know, taking that improvisational line, and the band is just like, you know, there's a band, there's a rhythm section supporting the soloer, and you know, if the soloer plays a note that might be different and not and unexpected, the rhythm section will respond to that in an interesting way, and that will then back react and impact the soloer, what the soloer plays next. So I found that my research style somehow naturally reflected how I played and what I learned, and sort of the culture of improvisational music, and of course jazz in general. And so I kind of wanted to explore that, and kind of like the chapters in that book explored, you know, what about physics had elements of jazz in it, and what about the universe in terms of had elements of improvisation and sound and acoustics and the structure, how we think, how music, some people say music is structured sound. Well, you know, we can have many different definitions for music, as you very well know as a musician. But as you give that definition, then one thing that I found to be very interesting is that the universe, and when we look at structures in the universe, like the distribution of stars and galaxies, that it has a beautiful resemblance and analogy with music, with structure and sound. The structure in the universe turns out in the early stage of the universe, as the universe birthed these structures, it was actually a sound or a resonance phenomenon. And so I found that to be really striking. It didn't have to be. The universe could have created structure, you know, in some other way.
If I'm understanding this correctly, sorry, I think I also heard you mention in one of the videos of yours that I was watching, that in the beginning was sound. Everything emerges out of sound in a way.
Yes.
So that taking this back to you know, different religious perspectives, I'm sure you've heard this and have thought about this, but in Hinduism, there's this idea that Om is the originating sort of sound source. I'm not saying that that's what you're saying, but it's interesting, the parallels. In the Islamic tradition, there's a strong idea that God says be, and it is. So creation, the creative process is an act of sound. In the beginning was the word, right? Of course.
And the word is sound. A word is sound.
Right.
I mean, if you want to push it to that level.
Right.
But yeah, I mean, in the early universe, it's an expanding system. So space is actually, you know, or spatial separations between, say, galaxies is expanding. So if you run the clock backward, the universe then there was a point where it was extremely hot and dense, and all of the matter dissociated into radiation, or what we call a plasma. This is basically charged particles that's in a soup of radiation, and it's very hot. But it turns out that's very similar to the surface of the sun. And those, you know, any system or medium, right, that has radiation in it, and right, that radiation carries pressure. So it could carry pressure waves. Well, guess what a pressure wave is? It's a sound wave.
Wow.
Right. So the fact that sound travels in the air is because the air really is like a fluid, right? And it basically, the vibrations are pressure vibrations that's carrying, right, the sound waves. Now that's why if you're underwater, you can still hear sound, right? Because you don't need air. It's the pressure waves having to do with the water molecule. So different mediums can carry sound. So the early universe, the vibrations of the early universe, right, had certain resonances, and those resonances carried energy, because sound waves carry energy, right? If that's why if you're in a dance club and the bass, and the speaker pushes against you, right? So it carries energy. That energy creates basically, creates regions of high compression, so a lot of matter, right, in the plasma, and lower pressure. The regions of higher pressure eventually become the first stars, right? Once you have stars, then you have planets and so on and so forth, and then life. So I found that to be interesting. But things get even more interesting when you start going, say, well, what created the sound?
Right.
And you know what? We have a theory. We have a theory for that, but actually we don't know. We still don't know.
Right.
And in fact, you know who invented the person that found the solutions of Einstein's theory of relativity? It was a Belgian priest who actually had a PhD. I think he had a PhD from Cambridge, from Eddington, the person who confirmed the theory of general relativity. Wow. And he was a priest, and he had this conviction that, of creation, being something from like maybe God, right? Or some being supernatural being created the universe. And then he called the Big Bang, who was the father of the Big Bang, but he called it the primeval atom, that the universe was this tiny atom, and it dissociated into this Big Bang and became the expanding universe. But it started from the singularity, where space, I think they call it the day before there was no yesterday. It was the moment of the Big Bang, because it was a moment where time itself began.
Right.
And so here's a question, right? How do you think about a past where there was no time?
Right.
Right. And this is a space, I think, where when you talk about, if you use the word like spirituality, I don't know how to talk about spirituality. I don't have in theology, but I would say that it's definitely spirituality begins where these sort of logical associations that we make, like, for example, we use the concept of time to talk about the beginning of something and the end of something, for example. But how do you talk about time, before beginning, or when time was right? Yeah. So that's a place, I think, where, okay, maybe we have to go beyond like the way we think about physics, the way we think about these concepts, these axioms, right? It's just like Gödel's incompleteness theorem, right? There are always some basic assumptions and axioms that we make in order to have a system of proofs. But you can't use those. You can't use the system itself, the things that you prove from the axioms, to actually prove the axioms themselves, right? Or to legitimize the origins of the axioms. So anyway, so that's my spiel.
Well, no, that's amazing. Thank you so much. So this the question, the sort of epistemological assumptions that are being challenged, they're being challenged because of some of these things that you just outlined for us, right? That our sort of day-to-day way of making sense of the world completely falls apart when we take things far back enough, or even without going back to the Big Bang and before. Just
how about right here and now? I mean, like, for example, we would love to, and this conversation is being expanded even into physics more so, but on like consciousness, like, how is it that, I guess there's many different levels of asking that question. I'm certainly no expert, but I would say that physicists are now starting to pay attention to that for our own problems, like quantum mechanics.
The very question of consciousness itself.
Yeah, I mean, we don't have to go all the way out to the outer edges of the universe or the beginning of the 15 billion years. Right here in front of us, I mean, there's, the most direct experience of our physical world is this word that we call consciousness, this self-awareness, the qualia, the perceptions that we have, the sense, the subjective sense of touch, vision, the five senses, right? Some people say that thinking is a sixth sense, right? Thought, or as Albert Einstein, I got a great Albert Einstein quote. And by the way, I'm going to be one of these poor souls that from time to time, I'll be
Please.
quoting Einstein.
That's awesome.
But I think here's a great quote. I think that that I think captures some of this mystery, because you know, he kind of is singularly the person that. So he was asked, I believe, in the 40s. You can double, maybe I think it was the 30s. He was at Oxford University and was asked the question, "How did you come up with the theory of general relativity?" Okay, you know, the theory of general relativity is actually so beautiful. It uses this piece of mathematics that is so beautiful. It's called differential geometry. And the way to think about this, many of us heard about something called calculus, which was invented by Newton. And calculus basically deals with like the connection between studying, you know, surfaces and geometry, and analyzing, you know, surfaces in the name of functions, right? So you can do something called analytic geometry by analyzing and manipulating equations and differential equations and integrals, things called integrals. And you can relate these things to each other. So, you know, you start with a coordinate system, X, Y, Z, you know, you plot, you know, you have a nice little curve of function, and there are all these beautiful functions that you can then use, right, to study motion, to study gravity. And what Albert Einstein showed was you can do the same kind, you can study these curves without resorting to any coordinate system. So you can be in some arbitrarily curved world, not even know that you're in this curved world, and then use this form of mathematics to analyze and know how to manipulate this world, right? And that's his theory. That's how you're able to, in general relativity, understand that gravity is nothing more than an effect of the warping of space itself, right? So gravity is not really a force per se. We experience it as a force, but really it's just a motion of objects in through the contours of a curved space. Okay.
Right.
And he was asked, how do you come up with that? And it was a major breakthrough. It's been confirmed, every single thing that the theory predicted over 100 years. Recently, the picture that we saw from the Event Horizon Telescope of a supermassive black hole, you probably saw that all over the news.
Yes.
That's a prediction. That's a prediction of general relativity. Wow. So he was asked this question, and here was his answer. A new idea comes suddenly and in a rather intuitive way. That means it is not reached by conscious, logical conclusions. But thinking it through afterwards, you can always discover the reasons which have led you unconsciously to your guess, and you will find a logical way to justify it. That's Albert Einstein. So I want to ask you, what does that mean to you?
Yeah, I mean, I remember reading a number of years ago, and you can correct me if I'm remembering correctly, or if indeed where I read this, they were describing it correctly. So describing how supposedly Einstein came upon, you know, the theory of relativity. And he sort of described this process, a very intuitive process, whereby he was apparently sitting on a hill with his eyes sort of half closed, half open, and light sort of shining on his eyes, and sort of being sort of refracted through his eyelashes, and in a flash of a flash, he experienced this, saw himself sort of traveling to the ends of the universe on this beam of light and come back again, and if I'm remembering correctly, and that was when he intuited the entire theory, and he later went back to prove it through the sort of the more traditional, or, you know, the sort of the rational modes of thinking, the ratiocinative. So so in the context of traditional metaphysics, this makes very good sense, that if one reads someone like say St. Augustine, or any one of the great theologians historically of any tradition, they had a very deep, profound understanding of the function that intuition, the intellect plays. So the intellect for them was not equated with reason, as we tend to do now. We just see intellect and intellectual as the same as rational and reasonable, right, in quotation marks. For them, the intellect was something higher, and it was this sort of divinely inspired aspect of the human being, whereby, as it were, the divine light was shining in it and sort of happening in a flash. And the rational faculty, which was lower than the intellect, would then, which is also ultimately, from a religious theological point of view, is still, of course, divinely inspired at the end of the day from that worldview, but it's sort of a lower order. But that serves the function of the intellect. It's in service of the intellect. So, and that's kind of a long response to your question, but
that's very interesting. I mean, one of the things I'm curious about is, so here's an interesting fact, scientific fact. So we can at least know about the past of the universe going back to 13.8 billion years ago. So we have a fossil picture of that. And that's when the universe is just filled with radiation and energy. And there was no stars, no galaxies, no structure, no people, no life. And imagine that that's what the universe was. Just imagine that it was just a sea of energy and radiation. And then as it expanded and cooled, it formed what? Galaxies and stars. Galaxies are just systems of stars rotating around like a frisbee. It created all these galaxies. And at least in one of these galaxies, okay, we don't know, I have my own opinion, but one fact we do know is in one of these galaxies, this universe evolved to wake up. What do I mean by that? By creating life that evolved from a universe that didn't have life. Those things, those entities were able to look back and see the universe. Right? So the universe, in a sense, I mean, one narrative is that the universe was a system that was not able to see itself, but it eventually created things from itself that's able to see the universe. So in some ways, if we consider ourselves as not disconnected from the happenings of the universe, we're not just this planet, like, flinging around in outer space. In fact, we know that the universe had to do a very interesting dance of entropy and disorder. The second law says that as the universe expands, if you believe in the second law, that entropy is always increasing and tending towards more and more disorder. So if you form planets and stars, you actually create order, complexity, self-organizing, systems like life. How do you do that? Right. How do you create entropy? While entropy is increasing, right? So the universe has to go through this very interesting transaction of extracting entropy out, right? And putting information in these systems. And that's a very interesting fact, that it's able to do that and not just create entropy as it expands.
Right.
It's able to create these structures. And what's interesting, the most interesting structures that it created is life. It's life. We emerge from that. All right.
Especially conscious life, right?
Especially conscious life. And a big question for me as a cosmologist, I'm actually interested in putting the universe, I study, one of the things we work on is the origin of the large scale structure, the structure in the universe. Galaxies and stars from a primordial universe after the Big Bang, where there was no structure. That's what we do. We do calculations and compare with satellite data and the stuff. That's the game we play, because there are certain puzzles. We want to see why do we do this as physicists? We want to understand how well our laws of physics, as we understand today, could actually explain those observations. And we can do pretty well, but it actually is a good litmus test and a good measure as to what type of new physics we may need. And I think a big mystery is the origin of life itself in the context, not of our planet and our ecosystem, but also in the context of our universe, right?
Which, as you say, is constantly expanding and in a state of extropy, right?
That's right.
Wow. And so what are some of your intuitions and inklings as to how, what seems almost illogical, right? That if say, again, to use very layman's terms, an idea that comes to mind is like an exploding something, an explosive device. If in that explosion that's happening, at the same time, it's bringing particles from that explosive device together into some coherent shape, functioning fully functioning, and it's sort of, if that's a good enough metaphor, first of all.
A metaphor of what, though? I mean,
Of the expanding universe.
Yeah. So one interesting thing about the expanding universe and the Big Bang is not a lot. This is the bad.
Yeah.
It's a fault of scientists that have not made that clear to the public, that the Big Bang was not an explosion. It was actually just an expansion from a very hot, dense early state. There was never any explosion. All right, but in terms of going back to this idea of like the connecting the origin and the emergence of life, such that life is able to, the universe is able to know itself and see itself by creating these structures, these systems, self-organized complex systems that are able to reproduce. I mean that we fit into that category of living things, but we also have the agency of consciousness and perception. And how do we understand that in the context of the happenings of our universe? That's it's not just biochemistry, I believe.
Of course.
And so but this is, I think, where we need more. And I think that at least I've been a very avid reader and practitioner in some respect. And this is the first time I'm saying this in public, because I've never. What's the word? Proselytize. There's a word where you kind of, if you is that the correct word?
Proselytize.
But because I have my own personal, it's more for personal development and do my very best as a flawed human being to try to be better in whatever little way I could. So I've been a practitioner of Zen. I mean, I've tried other forms, Vipassana, insight meditation, non-dual self from Maharishi Ramana's tradition. So I've always explored that because I had, when I was a kid, I remember, and let me just say, I'm going to use the word subjectivity. There's something, so physics is about, I mean, the idea of like, the realist stance of physics is that interpretation, philosophical ontology of physics is that there's some external world that's happening without us being there or being involved or perceiving it. So if we disappear, the universe will be doing its stuff. The laws of physics will be doing its stuff. There's certainly evidence of that because we see a universe, we see evidence of a universe of the past where there were no planets to support us and life. So it's clear that the laws of physics were functioning. But one interesting thing about the laws of physics that we don't completely understand is the notion of emergence, an emergent phenomenon. Like we have examples of that already. Ants all walking together, the individual ants have their own local interaction, but somehow they can collectively make a bridge so they can cross over an obstruction of water. So we see all the ants, the swarm-like behavior. Some people believe that consciousness is some kind of emergent phenomenon, called an epiphenomenon, right? So we don't understand that type of stuff too well. We understand some of it in the sciences, but there is this thing, I think we can all agree that consciousness is a subjective experience. We would love to understand how it is that neurons and our body and all those interactions can sort of, how this experience, this qualia, can be explained from just that. And some people believe you might need more than that. That actually can't, like my friend David Chalmers at I think he's at NYU.
Yes.
He believes, his idea is that the same way like the electron has an intrinsic spin and it's a fundamental quantity of nature, masses of, there are fundamental fields like electricity and magnetism, for example. He believes that consciousness is a fundamental aspect of nature, and every bit of matter, I guess it fits into the monism philosophy.
I was just going to say, this is very in keeping with a lot of traditional perspectives. Yeah.
Does this? I'm just curious. Does this exist in Sufism, for example? I know it exists in Hinduism.
Yeah, interestingly, yes. If one reads, for instance, someone like Rumi, Rumi talks.
Oh, I love Rumi.
Yeah, he talks about, and there are traditions going back to, the Prophet of Islam himself, where that describe, things having consciousness, and even objects having a type of, not just a type of, but a literal, they have rights. You know, there are correct ways to do things, to treat things. And not only animals, but even things, how we fold clothes, right? It's something, I mean, Sufism really does have this profound sense that everything, so the Sufi worldview, of course, is monotheistic, right? And the idea in Sufism is, there's, you know, what's central to Sufism is this understanding that everything, and Sufism is just, it bears repeating, it is just the mystical dimension of Islam. And Sufism historically was never apart from the Islamic tradition. It grew out of the soil of the Islamic tradition, and the fact that even many Muslims today think Sufism is some later accretion, you know, speaks volumes about where people are intellectually, and there's a whole complex history as to how that came about. Colonialism, surprise, surprise, played a huge role in that,
right,
consciously and unconsciously. But from the Sufi point of view, all of creation hymns the praise of God, the praises of God. You know, Rumi uses this language, the Quran has this language throughout, that the world of creation is there. The entire cosmos is a sign, or is a book of signs that we are meant to read in order to come to the realization of the, and this is sort of very Islamic language, but of the reality of the creator behind it all, who is ultimately ineffable, who is neither he nor she, and so forth. This is the Islamic perspective. So, yeah, anyway.
Wow, well, that's powerful. Well, one, I mean, I think, good, that's interesting. I mean, one, I think, interesting take, it comes from, so a lot of the people that formulated quantum mechanics were also involved in mysticism. So when Schrödinger studied the Vedas, Niels Bohr, another founder of quantum mechanics, deeply studied the Confucianism and the Tao, Wolfgang Pauli worked with with Carl Jung. Pauli, you know, the Pauli exclusion principle, you know. So
and Carl Jung himself was heavily influenced by mysticism, of course.
That's right. And that's just to name a few. Obviously, Albert Einstein. So the thing that's interesting is a lot of you see an interesting resonance with the concepts and paradoxes in quantum mechanics. Like, for example, complementarity. You think about complementarity, that's a key idea in quantum mechanics. Yeah. So in complementarity is this basic idea that that matter, or the quantum entity, seems to exist because it has opposing features. Things that are in opposition and contradictory is actually necessary for the thing itself to exist. So for example, the electron was once thought to be a particle and is discovered to actually have a wave-like nature, but a wave is in opposition to a particle. Wave is an extended object, right? A particle is something that's a point-like, you know, non-extended object, right? A particle can have collisions, you know, waves can go through each other. But the electron is both, and actually those opposing aspects of makes the electron, it's what it is. You need both to make the electron work. And so Niels Bohr actually hypothesized that all quantum entities necessarily have, you know, many different sort of, you know, opposing features, and it's necessary for the quantum mechanics to do its magic. You need the wave-like nature and the particle-like nature, right? There are other things that are complementary to each other, and they appear to be very opposing to each other. So locality, non-locality, you know, a quantum entity can have both at the same time. So that came from the idea of the yin and the yang, the Tao, right? right? You can't have the yin without the yang, and the object geometrically represents that. The minute you draw that division, right, and you fill in white, you necessarily have the other one.
And also interestingly, the white contains a drop of the black, and the black contains a drop of the white. So
very interesting point.
So they're interconnected in a deep way.
That even makes this analogy even better, as you just said, because the wave and the particle are actually interconnected mathematically. A beautiful piece of mathematics called the Fourier transform. Very simply put, you can describe a wave as a kind of a function. You probably heard this thing, a sine function. And then you can get a particle from that, or you can get a point by transforming that wave by a mathematical operation. And it becomes a point particle. That's a point, and that's things called a delta function. That transforms something called an integral. The minute you take that integral over this sine function, right, you literally get a point. So you can transform one to the other, and that's kind of like, that's the analogy, that pushing the analogy with the yin and the yang.
Right.
So that's
so the importance of mysticism, as you're saying, historically in the development of theoretical physics,
yes,
is deep. It's there.
Yes. And by the way, and to make it even more interesting, let's not. I mean, that's just in the West. Tremendous developments in physics also happen elsewhere in the world. In India, there are a handful of Nobel Prizes. In Japan and China, right? And if you now look at the narratives of how those, physicists came up, from the East, they were heavily into mysticism, right? They studied the Vedas and Zen and all these. They made now links with that. So we're not too far from those the doing of physics and how ideas come about. It has historically been heavily influenced by mysticism. But the point I want to make is, what does that say about the question I'm asking now about the universe creating life? And I have this intuition, but it's not only my intuition, that there is this. How do you reconcile that we are these tiny beings in this vast universe, but we have this one not special, I don't want to make it special, but unique capacity to actually perceive the universe and to actually figure it out in some respects. Albert Einstein says, the most incomprehensible thing about the universe is not how mathematically complex it is and how difficult the concepts are. No, that's also that's also hard. But even more incomprehensible than that is that it's at all comprehensible. He said that is the most incomprehensible thing. So let's push that a little bit further. So we have this capacity in the entire universe to know this universe, right, that we are a part of, or turned around. The universe did that to itself through its evolution. And this points to me to some of the experiences of enlightenment that some humans have had, which is like, even though we're separate, there's been accounts. I want to read one account, the so-called Kensho account. I want to read this actually, because I find it to be interesting. Again, I'm speculating, right?
Well, I think speculation is very important.
So there's the word called Kensho. Kensho, I'm just reading a quote here. It's in this new book that I'm writing. Kensho is a Japanese word that translates into what Westerners call enlightenment, a liberating experience recorded by Siddhartha Gautama, the historical Buddha. According to the Buddha, this potential to experience Kensho, or this human potential to experience Kensho, is accessible to all humans. Similar accounts of the Enlightenment experience was recorded by individuals across different cultures and religions. Meister Eckhart calls it a breakthrough. The theologian, Saint Simon, calls it waking up. And he says, he quotes, "I wasn't there. There was only the tree, a sense of utter liberation and bliss. It is overwhelmingly positive. It is like being drunk, but on reality. It is more real than real. So I'm wondering somehow if like there's this already function of consciousness where this idea of being one in terms of a subjective experience, being one with this physical universe. And I tell you one thing, I definitely, maybe I was crazy, but I was a 6-year-old kid. I was sitting on top of a hill in the southern coast of Trinidad, which is where I'm from. I was just a simple 6-year-old kid playing on this hill. And I used to just sit on this hill and watch this beautiful, pristine Caribbean oceans. Venice, South America, the Orinoco Basin was 7 miles away. You could even see South America. It's just sit. And I remember one day I was just sit there, and I have this memory of not at all like I just perceive, I mean, viscerally in my body and as like I was not separate at all. Like the ocean was me. It was weird. It was, but I didn't feel, I didn't feel that was my body. It was my body. It was an experience. I'm not trying to legitimize any scientific thing.
Mystics have described
it was just an experience.
Yeah.
And
the experience is very much akin to that. Yeah. And
tell me more.
Well, I mean, mystics through all of history, across traditions, describe, as with the quote around Kensho that you just read out, they describe this moment of awakening, realization, enlightenment, but understanding enlightenment to mean the just realizing what is already there. That is, we are fundamentally one, that there is no ultimate separation, that the idea of separation is actually illusory. And it's a necessary illusion because this is how societies function, and one could explain it sort of psychologically as this is part of the formation of the ego and so forth. But in a sort of from a religious spiritual point of view, the mystic would say that if we get stuck in that ego identity, we really haven't fully grown. That the ultimate goal is to recognize fundamentally that I am the person I see across me, from me. You know, I am inseparable from that person and all of creation, to use religious spiritual language, the entire cosmos. The traditional metaphysicians have this very, and this again is true, can be found in with slightly different language, but essentially in the same way across traditions, the idea of the macrocosm versus the microcosm, right? That the microcosm, who is represented by this unique creature who is the human being, not special, but unique, as you said, this being contains within himself or herself all of the possibilities of the macrocosm. So the macrocosm is a mirror for the microcosm and vice versa. And part, in a very real sense.
So it's kind of like a complementarity in a sense.
Absolutely. And you know, part of the very real work that the mystic does is to recognize, and it's not just a theoretical realization, because it's one thing to know this theoretically. Oh, you know, I have my dog lying, you know, on the rug next to me right now. Oh, you know, my dog and I somehow one on some level. That's like nice theoretically, but to actually experience that, that's something else. And I think the experience that you described as a 6-year-old, and it's very interesting in sort of Sufi metaphysics, they talk about, you know, my sort of training is primarily in the Islamic tradition, so I'm still more comfortable in talking through Islamic metaphysical principles, but you know, Christian metaphysics speaks to this as well, especially Eastern Orthodoxy. But to stay with Sufi metaphysics, there's this deep, profound understanding that the child, the sort of the child who hasn't had all the accoutrements of socialization and education, and which are necessary but also a hindrance at the same time. the child has this pure, pristine experience of reality, which in many ways, a significant part of the religious spiritual quest is to re-realize this beautiful, the incredible curiosity that children have, and openness and connection. I don't think it's accidental what you at all. To use, I mean, from a mystical point of view, what you describe is absolutely akin.
What would you describe that? What would you describe that as from a mystical perspective? I'm just curious.
I would say that it was a very clear moment for you where you realized experientially the fundamental oneness that you have with all of creation, right, or of all of existence. You know, to use more modern, shall we say, language of physics, or what have you. I mean, I've heard you mention, and I've heard this mentioned elsewhere, that we are made of stardust. Like, we know this on a rational level.
That is a fact. That is a fact.
Right? That is a fact. Right? You mentioned that. I heard you say how carbon is created by suns.
Right, nuclear fusion and stars. Yeah, the star is a factory that produces the elements for life.
Right, so stars are factories of carbon, and without carbon there is no life, and so we are made of star stuff. So we know that the physicists and others, they know this theoretically, and this is through deep study and analysis that you've come to realize this. And interestingly enough, and this is sort of in keeping with a lot of what we've been discussing thus far, the mystic already knew that, right, experientially. And I for me at least, this is what I understand based on my studies and meditation and so forth, is that a very important part of the work that we need to do as a species is re-realize this experientially, that if I truly recognize, and again, it's easier said than done, I'm nowhere near getting there, but I have moments of clarity.
Yeah, I mean, join the club. I'm trying to get back there.
Well, I think we all are, right? So in those moments of clarity, I have a profound sense that the person I see walking across the street, he or she, there's this deep interconnection that we have. But to really reside in that place, if we can really reside in that place, then the question of injustice, like how can I harm, do unto others as you would have done unto yourself, like it becomes a matter of like it's not even an intellectual problem anymore. It's I must do unto others as I expect to be done to myself, because the others are myself. And so
yeah, I mean, the interesting thing is that one mistake is to take one mystery and another mystery and say, oh, they're both mysteries, they must be connected. So clearly, the mystery of consciousness and the mystery of the origin and the existence of life in the universe, but it's fun to play with those ideas, and and theorize about it. Right. Schrodinger also, Erwin Schrodinger in his book What is Life actually did say that there's really just one consciousness in the universe, and all these appearances of different individuals is just an illusion.
Right. Well, that's very Hindu language, right?
He was influenced by that. Yes.
Right.
Vedic, yeah, the Vedic.
Very Vedic.
Upanishads, the Upanishads, yeah.
Yes. And again, this pervades all the traditions. It's very to go back to something else that you mentioned today in our conversation, that the universe has this, and this is the problem of consciousness that you're working with as a physicist, and many other people are trying to figure out, that how is it that the universe is capable of producing these conscious beings, namely us human beings, who can then reflect back on it and see it for what it is. Now, if I take it back, like I can't help, like immediately reminded me of this.
I mean, what the universe did was it existed, it existed, just existed, and then things were created from it. And those things are able to see
Yeah.
The universe
in all its glory, right?
Right.
And so I'm reminded of in the Islamic tradition again, and I'm not saying this by way of proselytization, because I'm very complex religiously speaking, as I've already mentioned, but just factually speaking, this, and you see the icon behind me, so like I'm really not interested in taking, I'm not really interested in taking one particular position over another. I'm just trying to figure things out myself, genuinely. But there's this profound and interesting tradition in the Islamic tradition which describes, and God speaks in the first person. It comes through the Prophet, but it's called Hadith Qudsi, which translates as, sort of these sacred traditions, which ultimately God is speaking through the Prophet. And God says in the first person, I was a hidden treasure, and I was unknown, and I created in order that I could be known. And I created man. I'm paraphrasing.
Oh, that's amazing. That's beautiful.
I created human beings. And I'm paraphrasing poorly. And Sufis, they sort of riff on that, right? And they build on that. And they talk about how the human being, in its sort of unique capacity to comprehend and to be conscious. And of course, human beings aren't the only conscious beings. And interestingly enough, very fascinating studies are bearing this out. I forget the author's name now, but he wrote a book called Biocentrism, and he talks about, right, you may know him, maybe a friend of yours, but that all the animals have a unique type of consciousness that is specific to them. And speaking of subjectivity, radical subjectivity, like my dog's experience of the world is very different from my own, and he's not like a dumb dog. He is uniquely tailored for what he or she it's a she, what she needs. But the Sufis have this idea that the human being in its unique capacity to comprehend and be conscious is basically the I, the I, or the I even, the letter I, through whom and through which God comprehends himself or herself. So it's very, because again, in Sufi language, to go back to the Vedic language, right, that ultimately there is only one consciousness, and we're kind of illusory consciousnesses, as it were. So I just lost your sound.
It's like it's like, this is like a quantum entity, because a quantum entity can have multiple perspectives, multiple, like the electron. This is an idea called superposition in quantum mechanics. Very simple idea. No, it's not very simple. It's called a superposition of states. Think of superposition as an additive thing. So in other words, if I have a ball and it's sitting here and it's moving in a certain direction, that's one state of motion. It has a velocity and a position at a given time. So that's, a ball has a unique state. That's a classical non-quantum part. Quantum particle can actually be superposed. It can have more than one state. It can exist in more than one state at the same time, which means at its time, it can be the electron can therefore be in one electron in many different places at the same time. Right. So let's take this analogy and extend it to what you just said. If there's really, how do you reconcile one consciousness with many, right? Well, the many different types of consciousnesses are different superpositions of the one electron, right? The one electron being,
I love that.
Like the one consciousness, right? Yeah. That's a nice analogy.
I love that. That just gave me chills. Yeah, that's beautiful.
So we are all different superposition. Our conscious experience is just all different, multiple appear to be different. It's really just a superposition of one thing. Right? I got to include that in my new book. So thank you very much. I'll footnote you.
No, that's beautiful. Well, I think, I don't just think, I really fundamentally believe, as we sort of started off by discussing, the importance of having these cross-disciplinary discussions and these sort of disciplinary discussions, because I think we enrich one another, because we each, we all bring sort of unique positions and understandings of things to the table. And where do you think, what's the future, how does the future look for, what's on the horizons for physicists? Oh, your volume just disappeared again. Sorry. Yeah.
Yeah, that's a great. That's a question. I mean, a big part of what, you know, I think being a research physicist or a scientist, I think for that matter, is that a lot of what we do is trying to figure out what that direction is. Mm-hmm. Actually, right now, I think I can speak for myself. I do feel stuck in terms of what direction to go in. Mm-hmm. So I'm definitely focusing my attention on really trying to understand the nature of the Big Bang itself, like whether or not there was even a Big Bang, whether or not the universe may have emerged out of some other type of state that wasn't just, so like I'm playing with this idea that there was no space actually. Space didn't exist. Space just like how water vapor, how liquid can become the same molecules in liquid just all of a sudden becomes water vapor, a gas, right? That's a different state of the same underlying substance, right? Liquid to gas, right? Different properties, different physical types of properties, but it's made from the same stuff. That's an emergent phenomenon, actually. We call that a phase transition. We go from one phase to the other. Transition from one phase to the other by turning up the temperature. So could time actually be like the temperature, where what we experience as space and this continuum through which objects move in actually emerged from a situation where there was no space, right? So the Big Bang is to be replaced actually from a situation where the universe didn't have space. Why am I interested in this? Because we're trying to understand the nature of how quantum physics and relativity, Einstein's theory, come together as one unit, as one unified whole. And there are some theories of quantum gravity, which is what we're searching for in my field, this type of physics. Sorry, I guess you'll have to edit this out. Let me just let's pause for a second.
Yes.
I'm going to stop the video and deal with sound. We'll be right back.
Yes, of course. No worries at all. Yeah, yeah.
We were talking about the what's the future directions. Yeah. So definitely in cosmology, we're starting to, I think, really understand the nature of dark energy and dark matter. Understanding, I think, complexity, the idea of complexity, complex systems, and emergence, that including, I think, life. I think biophysics, like, we've been, for example, we'd like to think that viruses are these simple, like, the simplest forms of pre-life. Boy, their emergent behavior has been proven to bring, with these pandemics, right, humanity to its knees. So it's interesting, the simplest systems of life, viruses, right, can have outsmarted collectively the most complex systems of life, right? So what's going on there, right? Is there is there something about viruses that we're missing? Like, so I think like there's this field, this emergent field of physics, it's called quantum biology. It's trying to understand life in terms of quantum mechanics, and quantum mechanics as some aspect of life, of living things.
Wow. So this, I mean, brings us neatly back to, I guess, the original question I posed to you. To what extent do you feel these disciplines need to come back together again, as it were?
Oh, absolutely. I think necessarily. I mean, I think that the confluence again, and it's not in this, I'm in a musical if you want to call it group, it's more of a project with Melvin Gibbs, the great Melvin Gibbs, the bassist.
Wow.
And it's called God Particle. That's the name of our outfit, right? And we play at jazz festivals and we record, and also we compose together, and we use ideas. Some ideas I might have in physics, I'll discuss that with him, and then we kind of he's inspired more from, like, as a musical composer, and but the important thing is that when you do this, we believe that it's simply not enough to say, oh, here's this interesting concept of resonance and the structures of the atoms and DNA and its connection to music. The music has to sound interesting and good.
Yes.
So it's sort of like I definitely am that type of scientist that is most interested in serious engagements with, like, say, a theologian like yourself, or a philosopher like Lewis Gordon, or an economist like Glenn Laurie, or I have all these friends who I also consider colleagues, sociologists. I'm in a conversation with a social theorist named Mark Gould, and Mark and we're interested because we just said we're just theorists. And I asked one time, I asked Mark, I said, so someone asked him, what do you do? He goes, I'm a theorist. And he goes, and the person goes, really? He goes, what's that? And he goes, I work on whatever I want to work on.
Yeah.
You see?
I can totally relate to that too.
And that's great, because that means our palette and the kind of colors we can
choose much wider, yeah.
Much more, much richer. Yeah. And yes, you have to, if you want to get engaged, you have to learn the language and have some respect for the structures and the traditions and the complexity of the different subfields. But that's what a collaboration might be. You don't have to be an expert, but you have to have interest in the exchange. Has to be genuine, and you never know what you'll stumble on, and how that might influence your own field. So it's always paid off for me, and definitely this connection between my explorations, between my jazz and my instrument and my practice, how I practice that. It's definitely, even in ways that I maybe can't explicitly, articulate, it's definitely affected my physics research and the results and the discoveries that I've made, and even the way I ask questions and the type of questions I choose to work on.
That's beautiful.
Yeah.